Wait a minute. Okay, let me just say hello, just in case. So this is my cat, always saying hello every time you talk about Azure or anything like that. My cat makes an appearance. So this is normal, no worries. Once again, thank you very much for having me. Really nice to be here. Um, about some months ago, I think we did a session about machine learning. We had some technical difficulties, etc. But I decided to rebrand the session, and actually this time, although I did try to use this session with the same name, I still had a lot of old content. This current content, I've rechanged all of the content to focus mostly on machine learning, the actual learning of machine learning, not the technology itself. So this is the first time I'm demoing, I'm showing some of these slides with the current changes. So I hope that this will be okay. If not, it's the humans' fault, not the machines. I'm sure the humans' fault, and definitely not the cats. Definitely not the cats. So I will do something because otherwise my cat will complain a lot. Remember that if machines take over, the cats will be the only thing that will that will go against the machines, and the machines will be scared. They were scared of cats in the old Egypts, so they will be scared of cats even if they are machines. Okay, so session is probably sponsored by my cat. She's right here. And my name is André Melancia. I usually do completely crazy sessions, as crazy as you can get. I will try to keep this one a bit less crazy because all of the machines are watching. I am from Portugal, so somewhere in the, I'm not sure if you can see this in the map, but it's actually reversed. So I'm not sure exactly where I am, but somewhere here, if the metrics are doing fine, somewhere here on top of my head. So westernmost point of Europe, and let's let's see what we have for today. So many people are developers, DBAs, etc., even sysadmins or even power users, but everyone fears machine learning. Everyone fears AI, and basically because you don't know what it is. If you've been to university more than, I don't know, 10 years ago, let me just put my cat down here, otherwise this will be difficult. But if you've been to school for over 10 years, maybe in university, etc., you do not get you know the subjects about machine learning, etc., that people nowadays get that at university. So you might not have any idea what machine learning actually is. In practical terms, this is very simple. No one expects you to be a data scientist or an expert in statistics or mathematics to do machine learning nowadays. It's actually much simpler. The same way any IT person like a sysadmin is not expected to know things about the hardware, CPUs, etc. Okay, I'm a bit old school, so I understand how the CPUs work inside. This is my area of electronics. But if you are in the computer area, not electronics, you're not supposed to know how these things work. Same way when you drive a car, you're not supposed to know how the engine inside works. You have some pedals, you have some steering wheel, and you just run. It's like a black box that you feed fuel into it, and it just runs. And you can use machine learning exactly the same way. There are a few things you need to know how to use. In a car, you need to know how to use gears to start the car, stop the car, faster, slower, etc. So those kind of things you need to know. But actually, what's inside the box, what blows up in explosions inside the engine, that you really don't need to know. It's good if you know. If you are from an engineering background, you'll probably learn about this anyway. But no one is actually asking you to build an engine, right? You can just use one that's already bought. Okay, so let's try to see how we can understand, machine learning from an outside perspective. We're not going to deep dive into each individual algorithm because that's just crazy. Although some of these I will explain at least two of them, and you'll see how easy this is. Okay, but Some of the others are really, really complicated. So those, let's not go into that because no one knows what's inside. It's the machines do it. Okay. So before we actually continue, if you are watching on Teams, not later on a recording, you can actually go to Teams, and on the menu you can say turn on live captions, and you'll be able to see captions under your screen. These are now available for multiple languages, so this is actually quite good, and they do help if you are learning a session, etc. This is done live. So these subtitles are actually done by Microsoft's cognitive services. We're not going to focus on them, but you do know that the basis of those cognitive services that do speech to text, text to speech, face recognition, scenery recognition, and then describe what you see in the photo, etc. All of those things use machine learning in the background. Microsoft already does this for you automatically. All you have to do is to consume that machine learning using a web service. Okay, so these captions are no exception. They use it in some ways like that. This is not going to be the focus of this session. I do have other sessions that focus on cognitive services, which are, crazy enough, but we're going to focus just on the raw machine learning. Okay, so let's see how this is done, not entirely under the hood, but let's take a peek at what kind of things we can do with this. Okay, so first of all, big difference. What is machine learning? What is artificial intelligence? So let's start with artificial intelligence. So let's consider that we have any kind of problems that we need to fix. And this can be like, let's say you have a small mouse and then you give it a maze in a laboratory, and you have to go left, right, etc. And you have to find some cheese. Let's say it's a mouse, you expect to have cheese. If it's a cat, you expect to have a mouse. So similar logic. So if it is a robot, you put a robot in the beginning and you say, look, there's an energon cube somewhere in the middle. You need to find it. Okay. So the computer will try to find an intelligent way to do this. And, first year of university, you immediately have like algorithm classes and things like that that tell you that you can do some algorithms like depth first search, in which you have to go, if you go left and right in any kind of graph, you can try to go left for all of the things up until the end. And then if you don't find it, you go back one level, and that one you turn right. If you don't find it, you go back one level, and then the previous one you turn right until you actually traverse all of the graph, all of the tree that you are supposed to get. And then you map all of the places you've been to so you don't have to repeat it. Okay. So you try to find it. Is it effective? No, because if a human knows that the machine will try to go always starting from the left, in that case you put the thing immediately on the right and the machine will not know it. But there are some things, there's some knowledge from the past that you can use it. In many cases, these are called heuristics, which is a really terrible word. I'm not even going to try to define it. Call it magic, okay? From our point of view, this is more than enough. And that magic will actually take the information from the past, try to analyze it in some way that actually uses the machine learning we'll see next. And it will try to predict where the energon cube for that machine might be, okay? So one of the things you can predict is if it is completely random everywhere, the amount of time it takes to find it will always be around 50% of going through all of the maze. That's expected. That's basic statistics and basic math. However, if you have an actual human putting the energon cube somewhere in the middle of the maze, there will be some trends, because you never put it in a corner because you are afraid the machine starts in a corner and they will immediately find it. You have to put it difficult for the machine. You never put it exactly in the middle because that's just too obvious. You're going to put it somewhere, okay? So if you ask someone, give me a number between 1 and 10, this will be very difficult. First of all, they will never give you an even number. It's never going to be 2, 4, 6, or 8. Let's exclude the 10. Why? Because it feels even, it feels standard. So it has to be odds, okay? And it's never going to be 5 because that's in the middle, that's predictable, okay? 1 might be the case, 9 might be the case. Most people would choose either 3 or 7 because they are in that sweet spot where it's not exactly the middle or the corners, it's somewhere there, okay? It's weird, it's a human trend, but try to do this, just come up with, I don't know, some crazy form online and say, just go there and try to select a random number. And after a while, you figure out that the peak is going to be on some like the 3 and the 7 probably, okay? But you can try it if you want to. So the objective here is to actually solve any kind of problem using artificial intelligence. You can drive a car, you can even be an antivirus and using those heuristics to find new viruses that normally you could not predict. So based on trends of what the code is actually doing. So okay, I'm going to read some other file which I never knew before, and I'm going to try to modify that file to add some exploits like a virus, right? A virus payload. And that is a trend that you can detect with heuristics, with previous knowledge, etc. Okay, so there's a lot of things that you can do with artificial intelligence. Yes, it is always a problem because artificial intelligence can kill you, and I'm joking about Skynet and things like that, but you know, if you have a car, this has happened before. It can run over people, so you have to consider a lot of things before artificial intelligence becomes a nice reality that we can live with. Okay, so you know those basic Asimov rules in which you will not kill a human or harm a human or whatever. Good luck with that. Okay, because that's really not easy to implement. Okay, but this is artificial intelligence. It's a generic area, and the part that actually drives a car is going to be a specific application of artificial intelligence. However, if you do things like machine learning, it's actually a subset of artificial intelligence, and the objective is to actually get something, get some data. Typically for us as data people, we're going to use tables, tables based on, bank loans or just data about people or data about trends that you do for shopping or something like that, or just cybersecurity attempts of hacking something or just connecting to somewhere if it's legitimate or not. But in the end, our data is very tabular. Okay, so we get some tabular data and then we try to use it to predict things. Okay, so I'll give you some examples of this a bit in the next few slides. Now, what happens is that you try to find patterns on that data, and there's a lot of ways to do this. It can be just like a small graph. It can be just aggregating, clustering people, etc. There's a lot of things that you can do for finding patterns in these kind of things. Now, one of the things that you can actually do is you can once you do a training, and I'll explain what this is in a second. Once you do that training, you do most of the work. 99% of the time that it takes for machine learning is to actually do the training, is to actually read. It's like you go to school, you read a lot for a whole bunch of years, and then you do a job which is just to tighten a screw or something like that. That takes 2 seconds, but it took you like 10 years to learn how to do that. Okay, so in that case, machine learning will take a long time to process the information, and that can be even months in some cases. So let's say if you have petabytes of data to learn from, you are learning from all of that and building your model. Okay, and model can be one file or multiple files, and that file can be just as small as a few kilobytes or even less, or just a few bytes. With linear regression, for instance, you can get by with two variables that can be decimal numbers. Okay, just as easy as that. So not even 100 bytes, much less than that. Okay, just I don't know, 20 bytes at most. That would make up a small, really small model. But in most cases, it's a few kilobytes inside, at most a few megabytes. And that means that if you take those models and deploy those models either as a web service, so that you can connect to that web service and say, here's my data, please predict what's going to happen within a few months for this bank loan or something like that based on the data of this client. Okay, and you get a reply, maybe yes or no, give them the bank loan, don't give them the bank loan, etc. You can predict things like the weather, what's the humidity going to be tomorrow, etc. Good luck with that. That keeps failing lately because of climate change, so that's a calamity, but let's not go there. But in any case, you can also take that model, which is basically one or more files, small files, that are distilled from petabytes of information, and you can put that into a really small IoT device that you can put in all of your houses, and it will be small enough so that the device can actually feed the information into that small model and get it out. Basically, it's like running a function, gets out the prediction, and then eventually, because everyone's houses will have a lot of IoT devices will enslave us all and take over the world. Okay, so let's see how this can be accomplished, not the taking over the world part, of course. Okay, so we have a few types of algorithms, okay, or categories of algorithms, whatever you want to call it. It's not really that language precision that I'm using here, but basically you have supervised or unsupervised. What's the big difference? Well, with the supervised ones, you take a table and say, oh, look, all of these people in the past, like 10,000 people asked for a bank loan and they got it. And in the end, this one paid the bank loan until the end. This one did not. This one did. This one did not. So you basically have a yes or a no kind of thing, okay? An example of that is that supervised, to actually have the answer for that, which can be just true or false, or it can be an actual number, so a continuous number, so a value from 1 to 1,000 or whatever the value is going to be, that would be supervised. That means that you are providing the computer with the answer, and the computer will train for that answer, okay? So it gets the input data and it focuses on that output data to find the answer. You are providing the results, okay? You as a human are providing the results. Now, and that could be for linear regression, classification, etc. You can do a few of these. There are we'll see some of these in a second. But for unsupervised, that's different. Let's imagine you have an image with a face. You have no idea what to expect. So you cannot train this. You don't provide the result. You need to have the machine validate the result in many different ways. Another one is clustering. So if you are trying to detect trends in shopping, etc., you have no idea what to expect. So you have to leave it up to the machine to find out what's going to happen. I'm going to show you a few examples, and then we'll see what can be done with this. Now, before we actually go into the algorithms, we need to understand how these will be applied, how these will work. Okay, and in this case, what I do have is I have something like typical workflow for machine learning. And this is how things usually work, okay? So if you are a data person, for instance, you'll probably understand what ETL is, extract, transform, and load. You get some data coming in from, I don't know, a relational database, from some IoT devices, etc., something, okay? Some measurements for temperature from that IoT device. Whatever it is, you get the information, and then you have to process that information and try to make a prediction, okay? But before you do that, you have to train a model so that the machine knows what you are talking about and then can give you an informed decision. Okay, so before you do that, you start, let's say you have labels.csv. This can be any kind of table that you get in. Technically, it doesn't have to be a table, but let's assume, okay? So you have the data coming in with a few columns and rows, etc., or if you prefer features and rows or lines, whatever you want to call them, and then you take some data, whatever the data is, and then you have to normalize the data. So to normalize the data, let's say that if you have weird values, and this can mean a lot of different things. It can mean cleanup, it can mean normalize. One of the techniques that machine learning has is that it normalizes the values in most cases between 0 and 1. So if you had something like a percentage from 0 to 100%, just as an integer number, they would divide that by 100 and then get a value between 0 and 1, because the numbers between 0 and 1 as decimal numbers, as floating point numbers, are very practical for you to feed to machine learning algorithms. They use it a lot, okay? Another thing that you can do for normalizing data is that if you are feeding texts, for instance, you can normalize that text. So if you have, let's say, a country or something like that, you don't have to say the name of the country in long letters. You can just have the abbreviation, like 2-letter abbreviation of the country or something like that. That would actually be much more useful for machine learning because they only process 2 characters instead of, I don't know, some characters I use like 20, 30 characters for the name of some countries, okay? And also some countries' names have errors, uppercase, lowercase, etc. And this can be a calamity for machine learning. Shrink it as best as you can, have the data as simple as you can. That's the ideal, okay? You can also have, so for instance, let's say that you have a different kind of problem. Let's say that you have someone who was born in 1950, 2 people who were born in 1950. Now, in the year 2000, that person bought product X, okay? One person bought product X. And 20 years later, 2020, 2000 and a bit, we're still in the year 2020. The pandemic is a dream, okay? Yeah, or whatever. I'm kidding. But let's say 20 years later, 2020 something, The other person, which was also born in 1950, bought that same product X. Now, you can try to understand the reasoning for both of these people to buy the product, and you want to match if these two people are the same profile, so that then you can use that profile to suggest other products, etc. Reality is that these are two entirely different people. Why? Because yes, they were born on the same year, even on the same day. Yes, they bought the exact same product, but they bought it 20 years apart, and that makes all of the difference. I don't care when people were born, because that's useless. I care what age people were when they bought the product. So one of them was 50 years old, the other one was 70 years old. Okay, there was a big difference. Okay, there's a 20-year gap, and especially 50 years old is like a normal adult, 70 years old is like a retired adult. Okay, so they have different expectations for buying the product. In terms of natural health, in terms of so many, expectations for life, whatever. So they bought the product at completely different times of their lives, okay, in terms of actual age. So what you care about is never the birth date of a person. That's useless for machine learning. What you actually care is how old was this person when they bought this product. Oh, they were 50. Oh, they were 70. Okay, so that's the number that you write there. That's the important part, okay? And sometimes not even that, because if someone's 50, someone's 51, 52, 53, you can feed it to machine learning if that's your objective. Nothing wrong with that. But sometimes you aggregate people by age groups, okay? This can be useful in some cases. I'll give you an example. From 0 to 6, people who don't know how to read. And you can even separate smaller babies if you want to. From 6 to 10, that's like primary school. 10 to 18, high school, whatever. And then 18 to 25, university. You party a lot, right? You have fun, you party a lot, you have some shopping habits which are completely different. From 25 on, you start to work. So your needs in terms of shopping become completely different, okay? All the way up to 65. So you can divide every 10 years or something, and all the way up to 65. Then you retire, and from that point on until probably the rest of your life, you're going to be grouped in a different group of people. And that's your age groups working. It can be age group A, B, C, D, etc. Maybe 5 or 6 groups altogether. I'm not sure, but you group all of these people like this, and then you can decide what their trends are, okay? Because it's much easier to aggregate people by groups and then work it out, okay? So that's yet another way. Another way is you need to clean up things, you need to make sure things are okay. You have some nulls, you have some invalid data. So let's say you have a birth date in the future or a birth date 300 years ago. So you need to clean up some of these. In some cases, you just remove the whole line, the whole records of that person because it's too invalid. You have no idea what to do. Other times, you take that information that you have from cleaning, and if you feel that it's relevant to keep that person there, that record there, and if you have some blank fields there, you may just take the average of that field and use the average value on that field. So you're not really cleaning up, you were replacing with the average value for that field, so it doesn't affect the machine learning training. That could be a thing. It can also go terribly wrong, so you need to be careful if that makes sense. Each business is different, but you have to take time and try to work it out. Does this make sense? And sometimes you have to run a whole bunch of trainings like this a lot of times until you find the correct one. Actually, in most cases, 80% of the time spent on machine learning is not, let's say 99% of the time is for the training, and then of those 80% are for figuring out how to clean up things, how to prepare the data before you actually feed it into the training itself. Okay, so that takes a long time to prepare. Okay, so preparing is the actual trick here. Anyway, feature engineering, so to choose which columns you want to use. So because you want to use features or columns, these are the same things, because in some cases you want to ignore some columns. Let's say you have a social security number or ID card number. Let's say it's a sequential number. My number is going to be much smaller than the number of someone who was just born today, because I'm X number of years older. So if that's a sequential number, from a machine's point of view, they're seeing a number. So if they're seeing a number, they will associate that number with someone's age, because the older you are, the shorter your ID number is. So indirectly, you are feeding age to the machine learning, with exceptions, people who are foreign and join the country, and then they have a new sequential number, etc. But in most cases, you are feeding the date using one of those numbers, which is also sequential. So be careful. Those kinds of numbers should disappear. Any kind of ID, individual ID, which is an abstract number, which does not relate to anything, those kind of numbers should also disappear from the training. Okay, so once you clean up everything, whatever that is, typically you do one thing, which is you split your data, typically in two parts. So you split the data to do the training itself, which is like 70-80% of the data somewhere here, and then you have the other 20%, 30% to actually be fed here so that you do model scoring. Okay, so this is fairly easy to do. Okay, and pretty much this first part here will generate a model. So this line here will generate a model, which is an object, okay, a file if you want to, and that will train, all of this will train. This extra splitting is because you are doing hyperparameter training, so that means you run a lot of trainings at the same time, and then they split the data to handle this a bit better for you. Let's not go into it. Think about this as a single training object, okay? But when you go all the way down, that model will be used to calculate, to predict the results. And remember, the training can take months. The calculating, the prediction part, the inference part, if you prefer technical terms, that takes microseconds. That's why it works really well on IoT devices or cell phones or anything like that fed inside the applications. Okay, that's really fast. So once you do that, you can then compare with evaluations. You can do some math if you want to. This can be a bit of code. This can be graphical. This is literally a designer that you have in Azure Machine Learning. It looks exactly like this. So I'm not just creating this randomly. This is literally what you have if you use the Azure Machine Learning workspace. So at the end, you have an evaluate model that tells you, okay, out of the 20% that was left for testing, we were able to use the model and we calculated with good quality that 94% of the things were calculated correctly and the other ones were calculated incorrectly. Okay, so we have 94% accuracy. And by the way, depending on the algorithm, the name might be different. It can be accuracy, precision, it can be root mean squared error if this is a linear number. And in that case, you want that number as small as possible. That can be Spearman correlation, that can be other names, area under the curve, etc. Really depends on the algorithms. Okay, so I cannot explain everything in 1 hour. It's impossible, but I just want you to know that there's a lot of different definitions for all of this. Okay, so you have to figure out, should I have more or less in that specific metric that returns from the training? Some cases it's more, some cases it's less. So you need to know, you need to go online, figure it out, and you need to know it's not that bad. So from the training, we feed to the training, we feed the actual algorithm, which is a whole set of functions that does things, etc. Okay, and we'll see a few examples of those in a second. This one, for instance, is a neural network for regression, but you have options for regression, which is getting linear numbers like a line or a curve or something. Classification is getting A, B, or A, B, C, D, etc. Clustering is aggregating things, and then you have a few others, but you also have techniques like neural networks and deep learning, which are, and also decision trees, etc., which help build those algorithms. Okay, so we'll see how this works. And as I mentioned, after you do the training, you do the scoring or testing, get a prediction, and then you evaluate if that's correct or not. After you do that, you'll deploy, let's say, a web service or deploy that into an application or something. This is called inference. Now, the funny thing is that after this is all over, after a few months or I'm not going to say days, depends on your business, but typically a few months later, you'll retrain everything again. You get new data coming in, so your data sets will be updated with new stuff from the most recent experiences. The old ones, let's say the law changed or something, and something that happened 10 years ago doesn't make sense anymore, so you exclude those values from your future trainings so it doesn't affect your trainings. But whatever you do, you adapt the data to the most current situation, and you do all of the steps all over again. Okay, now let's have a look at some examples. First of all, regression. Okay, and this is easy. By the way, if you have any questions, you are welcome to ask. Okay, feel free to ask in the chat, etc. And I am here to answer them just because that's how things should be. Okay, so anyway, a few examples of regression. One of them is linear regression like this. So you have a whole bunch of dots, okay, and you learn this in high school. You get all the dots. Take a line that kind of resembles the dots. The formal definition might be something like getting a line that gets the shortest distance, aggregated distance between all of the points. Yeah, that's a weird definition, but yeah, you can consider that this is the line that best represents all of the points, and then the distance between the points will actually be the error. We'll see that in the next slide. But anyway, you can use regression, and this can be linear regression like you see here, which is literally a line, okay, or you can use curves and other things like polynomial, etc., to actually find a curve that fits to the data. Now, if it is this one specifically, it is a line, so the line will have a formula which is a plus bx, or ax plus b, whatever you prefer. But then the a part, let's say the individual part, is this number from 0 all the way up to here, so maybe 27, 28, so that's a. That's a value of a, plus bx. So b is going to be the inclination of this curve. So every time you have a value of 60 that you feed into the training, they will take that formula, calculate that formula, get the value here, and then they will find that the value, let's say 60 here, will be around 50 here, give or take, okay? If I'm doing this correctly, it's around 50 as the y, as the results, okay? So a plus xb, which is linear regression, come on, everyone knows this. Two variables, a and b, you store that in the model, that's the easiest one you can get. But that's the only one that you can get such a simple value. It's also the fastest machine learning one, but in most cases, you will probably need a curve instead of something like this, okay? So you can detect things like the weather, economics, any kind of trends, etc. Remember that for economics, this works like in a macroeconomic level. Don't do this for the stock market. Stock market is based on human panic, and that does not compute well with machines, okay? So anyway, an example of a curved situation. So a curve best represents this, and this can be like a simple curve or a zigzagging curve, depends, okay? This one is polynomial, so you can see that the curve starts doing the training in one way and then adjusts. This is a dynamic GIF that I got somewhere from the internet, and this helps a bit to actually find the sweet spot between those curves, okay? You also have 3D stuff, so you can even map things in 3D. Please notice that there is the dots that you see here in red are actually the real values, but the prediction is somewhere along this plane. Same way that the prediction is along this red line or this black line on the right, but then the actual numbers are a bit away. So the distance between the line and the dots, that's going to be your margin of error. Okay, so how does the margin of error work? Well, you have some bias in everything. You have some bias, you have some errors. And if you use a linear line, for instance, to detect a curve, that will not work. But if you use the blue line, that might work a bit better. But in any case, the blue dots that you have here, distancing from the line, some of them will be better, some of them will be worse. This will not mimic entire things properly. And there's actually the error. So you have a distance of error between the line prediction and the actual error. So these two at the far end are very far away. These are very big, okay? But in the central part of the line, maybe that's what you want to use. Those terms will be much smaller. Is this enough? Well, maybe yes, maybe no. There's a lot of algorithms that improve on this, but you have to decide which ones you want to use, okay? Anyway, a good example of problems you have underfitting. What is underfitting? Well, you just draw a line that gets the average of all of the dots. That might work well or not, probably not. And in the end, you get wrong predictions a lot. Now, an overfitted line would be something like this. You zigzag around to get the exact values, but then if you have a value that falls into this, which is still around the average, like where I have my mouse here, if you get a value like this, that goes well around the line, very far away from the line. But the problem is you had a line that used so much math to find a very precise line, but to the sample that you have, that you forget that the sample is literally just a sample of the reality. So this sample cannot be that much overfitted, which is the technical term. It needs to be reasonably fitted, like the one in the middle, okay? And this is a good fit. That means that the line will try to predict things around, and if I put the dot like I had here around here, in that case it will be very close to the line that I had before. That would be a good value. If it was here, it would be, even the line, the straight line would be better than the overfitted curve that has a distance of 3 mouses vertically, if I'm using my mouse as a unit of measure, right? So underfitting is bad, overfitting is bad, plus it takes a lot of training time, and good fitting is the ideal scenario you want to get as best as possible. Remember, if you are doing machine learning, you will never have a prediction that's 100%. You'll always get 90 something percent or even less, and that is something you have to live with. It's never 100%. 100% is doing a where clause in a SQL statement. That's 100%. If you do machine learning, it will never be 100%, otherwise you're doing something wrong. Okay, now here's an example of statistics problems. I'm going to show you one or two, which is, they are a bit funny. So you think, oh, this datasaurus, whatever that's called, that means your data has a lot of reality, right? Well, no. If you do the average of all of these dots, this is the end line. This is the average of the dots. And there's even an example with another dinosaur in which the line is just a straight line, because the average of one compensates the other and so on. So the average of all of this is just a straight line. So remember, the data can lie, okay? You have to see it in a graph. Even the graphs might be weird, but then the reality of the world might be different from the representation in a graph. So underfitting, overfitting, or just considering that just averages are not enough is something that you need to take into consideration to make it worth your while, okay? So anyway, you also have two class classifications, and there's a lot of things to talk about here: 2-class, 3-class, etc. You can have multi-class. What's multi-class? Well, you have to return a result of A, B, C, and D, for instance. So we have speakers in our event today. I didn't count how many nationalities, but at least 2, 3, 4, whatever, okay? And if you want to try to predict what nationality that speaker is from, you can try to predict in a number of different ways, etc. But let's say you want to predict that. Well, you need to get the you need to get the results, which will be country A, B, C, or D, for instance. That's multi-class. If you're just getting something like, can I have a bank loan, yes or no, that's usually a 2-class model, okay? And specifically, there is an algorithm called logistic regression that allows you to have just this. So in this case, you have things like, and the example here is for birds, but let's not go for birds. This is actually a joke on Monty Python. They talk about swallows, which is a special kind of bird, etc. But this is just a joke on it. But in any case, let's say that this blue ones and the yellow ones. So yellow ones are people who are taking the exam, all of this, and yellow ones are the ones that actually studied, the ones that actually passed, and the ones that are blue are the ones that failed. Now, the down here, let's assume that this is the number of hours you studied for the exam. So it's obvious the more you study, the more you pass, the more yellow you become. That seems very obvious. So if you don't study at all, you don't pass, okay? However, there are people that didn't study much and still passed, and people that studied a lot and still failed, okay? So this case, what you're going to get is a number. This is actually not a vertical line. It would be a horizontal kind of line. But in any case, somewhere in the middle, you would have a threshold that says, if I calculate this over this value, which can be 50% or a different value up or down, you can calculate the value and say, it's likely that this person will fail the exam or pass the exam, okay? So we'll figure out, okay? So in that case, you can predict those things based on past experience, past information. You feed it all into a machine learning, just a table into machine learning, and then you have the expected result from the pasts that actually happened, and then you can, based on that, try to see what's going to happen in the future, predict the future based on past information, okay? So this is not difficult, okay? Even a human reading a lot of text can actually understand, oh, there's a trend here. If this person is usually 5 years old, they're going to fail the exam. If they are 80, they're going to fail. If they are between 15 and 16 years old, they're going to pass. So yeah, the age one could be a very easy way to detect it. But of course, these can be used for anything like, as I mentioned, a bank loan, but it can also be used to, I don't know, pretty much everything that detects a true or false or an A and a B, or in the case of multi-class, A, B, C, D, etc. Okay, but there are specific algorithms just for two class, which are very optimized. Logistic regression like this one is one of them, and the return of this is a number between 0 and 100%, or if you prefer between 0 and 1, and that would be a percentage anyway. But 0% does not mean false, and 100% does not mean true. Sometimes it does, sometimes it can be the other way around, depends on your data. Okay, so you have to be careful. The algorithm doesn't really specify true or false, it's just an A or a B, or a B and an A. Okay, it's just something like that. So remember that the information can be confusing to understand. Okay, so sometimes if you torture the information, you can actually get different values, and that's something to mention as well. So I have some comments about this as well. Okay, anyway, clustering. What is clustering? And clustering, and I'm missing something here, so there's it should say data, but for some reason the size, I changed the way it looked, and for some reason this cut off. That's okay, we'll survive it. Okay, but anyway, multiple algorithms for clustering. The most typical one is k-means. So k-means has been created sometime in the 70s, so it's older than me, and it is used to aggregate all of these points that can be 2D, 3D, 4D, etc. So this does not have to be just like you see them here. This can be three-dimensional or even fourth-dimensional, and you can join them together. How does that work? I'll show you the next one. So before k-means, you start here. If you assume that you're going to have three clusters, in that case, you select 3 points and put them in the map anywhere you want, and then the map will pretty much find the closest point to it and make the points like this. If and then what you say is you move that centroid to the center of that graph, and you move it around, and then you recalculate the points, and then you can start with a point here, a point here, and a point here very far away, and they will actually move and generate different colors for different items until in the end you do this iteration X number of times, and after, I don't know, 10 iterations, 20, 100 if needed, they will probably not move again. So that means that if they don't move again, you get the values that show up here, and these will be aggregated. Okay, this is really nice. K-means is very simple. The only difference since the 70s until now, so 50 years, is that they added some stuff to the algorithms to optimize them. Everyone has added a bit, but pretty much the logic is simple. You start with n number of centroids, and then you try to move them around until you find the correct place, and there is mathematical operations just for that make it simple. Okay, so anyway, an example of that is also this one. So the centroids are here, one here, one here, one here, and the numbers will find the closest place to them. So in this case, someone selected 3, and they will generate this kind of thing because these are the closest distances to this. Remember, it's a 2D distance or a 3D distance. That depends a lot, okay? It depends because you can have a lot of different measures. And why do you use clustering? That's also the next question. You can use clustering for detecting things like trends in shopping. So if you buy this, you also buy that, etc. So you can have trends for same ages, so one of the dimensions can actually be person's age, other dimensions can be, different, etc. But for instance, this will detect all of those kind of things in a very easy way. Okay, now let me mention some examples where it doesn't work. Okay, let's say that once a month you go to supermarket and you buy wine, you buy diapers, you buy, I don't know, you buy toilet paper. Okay, so those kind of things. Well, is toilet paper related to buying wine? Does that mean that someone who buys toilet paper also needs to buy wine, or vice versa? The answer is actually no. So sometimes these are circumstances. People buy it because it's the end of the month, they just got paid, so they want to buy the whole thing for the whole month, so they buy it in bulk. Okay, so that means that in this case, toilet paper and wine are not related, but in other situations like beer and peanuts or something like that, it might be related. We don't know. Okay. So the thing is, you need to understand the actual business. You need to look as a human and think, does this make sense? Yes or no? Let me give you another example, which is if you ask a small child, and I asked my niece when she was very young, like 2, 3 years old, and I asked her, why do people get divorced? And her answer was very, very simple. And it's not because they found someone else, or they just don't like each other, or crazy things. Okay, it's simply because they get divorced because they got married, and that's 100% of the time. You cannot be divorced unless you were married before. That's a state machine. So you start by being born, blah blah blah, and then you get married, and then you get divorced, and then eventually get married again, so you go back, etc. Or at some point in time you die, something like that. But it's a state machine, and the previous state based on learning is always the same. You got married, that's why you're getting a divorce, and a machine will detect this. A small child which does not have the bias of social interactions, so they just call it as they see it, they will tell you the exact same thing. A normal human will say, oh, no, no, no. She liked someone else, he liked someone else, etc. They decided to get divorced and they are with someone else. That's not reason. Real reason always is because you got divorced. Another example of that is this crazy statistic, okay? I got this somewhere on the internet, and this is true. And if you consider that if you are an alien or a machine, you do the math and you figure out that the average that you have for this situation is one, because there's like 50% women, 50% men, the average is one. Does that make any sense? Absolutely not. It's like the dinosaur one, okay? But this is statistics, okay? We have to, some part of statistics are good, this kind of thing, and the dinosaur one are bad, okay? So you have to take into consideration the reality. Okay, so now we're up to algorithm techniques. So these are not the final algorithms, but these are techniques that are actually used inside of the actual algorithms to improve on learning. One of them is to use a decision tree. So there is an example would be a multi-class model, for instance, but you can actually do a decision tree by saying, look, I want to learn, and this can be implemented in a tree, in a table. So you can just create, I don't know, 10, 20 lines of code, and you can implement this just as easily with the learning part. So you can start by the information that's already stored in the system. Well, the one you see now, is it a mammal? Let's say it's my cat that's sleeping somewhere, and you say, is it a mammal? Yes. Do people use it as a pet? Yes. Well, actually, I'm the cat's pet, but that's a different story. Is it a hamster? So the computer will tell you, oh, according to my information, you have a hamster. No, I have a cat. Okay, so the computer will ask you next, what's the difference between a hamster and a cat? Well, the cat meows. Okay, so you replace this node here and say, does it meow? If it says yes, it's a cat. If it says no, we go back to this hamster. So you point the hamster a bit lower. Okay, and then you do the same thing again, and then you say with the dog, and then you say. So you have a hamster. No, I have a dog. What's the difference? Oh, it's this one. So you keep going up and down the tree, generating more leaves on the tree, more branches on the tree, until you actually come up with a classification tree that defines your reality. And the computer does this automatically. They ask questions. What is the difference? Why is this different? And that will generate this. And they will actually go and look at all of the fields that you have in a table. Let's say, if you are married, what's your job, how much money you make a year, etc. And they will build this tree. Now, this tree is just a binary tree, a very simple tree, but this can be a tree that has multiple data inside without just being a yes or no kind of thing. Okay, so it is perfectly possible to have something like that. Okay, I'm going to keep it simple, just leave it like it is, because otherwise it will generate some confusion. But if you are curious to know how this is implemented, there is something from the 90s, so it's been around for at least, that I remember, 25 years, probably much more. This has been around 20questions.net, 20q.net. So they ask you for stuff like, Star Trek, films, etc. Really nice stuff. A lot of things. Try in English, which is the most complete one. But they ask you a lot of things, and then they will ask you something like 20 questions. And then they will say yes, no, etc. So this is not a yes or no tree. It's a yes, no, unknown, irrelevant, etc. So there's a lot of combinations here that might not be entirely what you expect. So their implementation is very specific, but in any case, they will use decision trees, but they don't use one. They use a lot of different decision trees. And think about this from a SQL perspective. Each tree is like a table. If you have questions from multiple tables, you then join the tables together. So the possible answers for one of the tables plus the possible answers for all of the other tables, it's like you do a SQL join on the trees, okay? So in the end, you get the result that matches all of those things together. If you say something is irrelevant, that means that you're asking thing about a specific tree that you're actually going to say, oh, this is not part of the problem. So let's get rid of the tree. So it's like removing that tree from the join. Okay, so you can do crazy things with this. And this is actually one of the bases of machine learning. Another basis of machine learning is things like neural networks, where you implement simple neural networks with inputs, outputs, and then somewhere in the middle you have your nodes to process a lot of information. And this actually takes a long time to run, but it gets you the better results. Okay, so you can do this for imaging like face recognition, etc. But you can also do this for just normal data that you have in a table if you prefer. Okay, sometimes this is called deep learning. Sorry, sometimes this is called deep learning, and you can use this very easily if you want to. Okay, anyway, there is a cheat sheet. If you go to aka.ms ML cheat sheets, you actually have this cheat sheet. I'm going to share the link in the chat. If you are watching this as a recording later, it is actually down here, ML cheat sheets, okay? And you have this on GitHub somewhere else, and they tell you what kind of things you have. So you have two-class classification, and you can see you have a lot of different algorithms. Each of them has a specific characteristic. So this one says accurate, this one says fast, this one says something else. So you can choose the one you want. So remember, is this A or B, true or false, etc. Okay, is this A, B, C, or D? So in this case, you also have a few ones, and then, oh, this is fast, this is accuracy, this is something else. Image classification, so you can do classification with neural networks. You can do simple regression, which remember is like a number with curves or linear, and some of these are accurate fast training times. It's a decision forest, use a decision forest. But neural network, so using a neural network regression, long training time, so that's going to be slower. Really fast linear regression, fast training linear model. The bigger your data grows, the time grows linearly to that. But some of the others, they will grow exponentially. If you double the data, it will exponentially increase the amount of time it takes to train and maybe the RAM it needs to train. You can also do text analytics, anything not language related, and you can also do clustering, anomaly detection, recommenders, etc. Okay, recommenders are not that much different from recommenders allow you to get information about give recommendation, let's say videos and stuff like that that you see on YouTube. Oh, if you like this, you like that. It's actually not that much different than clustering if you think about things like that. Okay. Anyway, machine learning in Microsoft's universe is simple, okay? There's a few examples of the things that we have. So I'm just going to leave this here. I'm not going to spend too much time on this. So at the very beginning, I mentioned cognitive services, bots, or Power Virtual Agents, which are basically bots as well. But you also have a lot of different machine learning techniques and infrastructures in Azure. I will show you very quickly. I have 2 or 3 minutes. I will show you that you can create one in Azure Machine Learning and then leave this up to you to have a look at this later on, okay? But pretty much you can do it in Python, you can do it in R. Remember that there are algorithms like scikit-learn, like TensorFlow, PyTorch, etc., that you can use. Some of these are actually available for multiple languages, although nowadays Python is the most interesting language of all, but you can actually do all of this with a lot of languages. And remember, the magic here is not the language. Python and R look terrible. They're ugly languages, okay? But you can actually use Python using a lot of different libraries that are very good for machine learning. Now, the only thing I really want to care about here is if you use the SDK, and I'm running out of time, so I will make this quick. If you use the SDK, you can actually use you can actually deploy infrastructure, like create a cluster that runs your training, create a web service to run your predictions, etc. So the SDK includes all of that automatically. AutoML is easy, so you can run machine learning training without knowing anything. Just click a button. Hyperdrive, etc. Can use a lot of different trainings at the same time, so they do it for you as well. Model registry, you store all of those models in the system, and then use the one you want. You can just click on a button and say deploy. Okay, so that's actually very easy to do. Okay, and to do that, we need to have a very, very, very quick demo. Okay, so first of all, you need to go to Azure. If you don't have Azure, click here, try Azure for free. So azure.com, try Azure for free. That's easy. And you get to a place which is your Azure portal. So portal.azure.com. And here I have my portal, which looks different probably from yours. I'm always looking where Skynet is going to be located. You can click on the plus sign and you can just say machine learning. Okay. And then, oh, wait a minute, not this one, not this one. Okay, wait a minute. So machine learning. Okay, just make sure it says Azure Machine Learning and it says Microsoft here, because there's a lot of things that are called machine learning. Okay, so what's the learning path? Okay, so if you are okay with this, I will answer this in just a second. So you choose your subscription. This is how you pay for it. You associate a resource group, and then you give it a name, and all of the rests, they can just generate automatically, okay? In the end, you say review and create, and you are there, okay? So I have my NDML one that I've created before. So this one was already created like this. It takes like 5 minutes, okay? So you can actually go here and click on Studio, this address, and you jump into the studio. Now here there's a few things to mention. So you have the automated ML. So you can go here and say new automated job, and then you can say create from your local files, from open data sets, and the open data sets have things like the diabetes data sets and a few others. You can choose and create one. I've created one that says diabetes. You go next, and diabetes has a lot of different fields like blood pressure, etc. And the last one it has is the value that you calculate if you have diabetes or not, which is the number that should be around 90 to 120 in the end. But you go here and you say target column, that Y column, which if you see it as Y, it's usually the destination column, and then you give it some name, etc. And then you run it in a specific cluster. You can create clusters. If you go down here, you just create a cluster. That's easy. Give it a size, etc. So you can just create it, and then you can select the cluster, okay? And then you say next, and that will start to run. You choose classification, so A, B, C, D, etc. Regression, which is a sequential number, or time series forecasting, if you want to predict what's going to happen in the future if you follow that line. So then you click next, and the training will start. I'm not going to do that. The result is something like this. So if you go to AutoML here, I have my diabetes experiment. This is the results, okay? So the result, if I try to show all of the trainings that happen, so give me a second. If I try to show all the results, so child jobs, because this AutoML tries with a lot of different algorithms. So you have all of these algorithms that they generated automatically. And this was about an hour ago, okay? So you can generate all of this, and then you figure out that the bests is probably going to be one of these, okay, one of these around. So if you try to see it, all graphically, it's going to be one of these top ones. I'm not sure which one it is, but one of these will have like the smallest root mean squared error or something, and the Spearman correlation is also reasonable here. So it's going to be one of these. Probably one of these two will be the best. This one doesn't seem correct, but then again, we need to have a look. So we can click on each of these and figure out which one is best, okay? So each of these are different algorithms, and we can figure out which one would be best in this scenario, okay? So I can go here. In any case, I can go here and see others as well. Another thing that you have besides the automated one is the designer. And the designer, you can just choose something. And I chose the first example that was available there, okay? And then you can actually see that you can generate these kind of things that we saw before, okay? And if you want to add something to it, you can actually execute a script in the middle of these boxes, or just run a specific training, fast forest, quantile regression. So you drag and drop and put it there so that it runs certain things. It's like drag and drop, not very difficult, but of course this is a very beginning introduction, very difficult to show everything. This will take weeks to show everything. However, you can go to notebooks, you can click on samples, select how to notebooks from samples, and then you can click on clone and run them. I've had one of these, which is image classification, actually run. So it's actually run here in this notebook, okay? So I'll actually try to show you the results. So you can actually run, and apologies to the next speaker, just give me 1 minute, okay? But in any case, you set up this as a notebook, and then it starts to run things automatically. One of the nice things is it connects automatically to Workspace, just with this line, that's it. And from this point on, you create an experiment that will be visible here, so you can analyze the results, but especially you can create a cluster just like this. So this is getting a variable to define the size, but the actual getting of the cluster is, if the cluster is available there, all you have to do is to start it. If not, you need to create a new cluster by using one line of code, just saying this. It's very, very, very easy thing, okay? So you can create this from here, and then you get results that are numerical, etc. This MNIST classification tutorial, try it out, try this one, and then try the prediction parts, which, so image training and then image deployment. Try the two of them in sequence, you'll find them funny. Okay, so endpoints here are the results. So I don't have an endpoint here, but this will be the web services that you can run as containers in Kubernetes services or somewhere else. Okay, so in reality, all of this is very nice to use. Give it a try. If you go to the home, so if you go to the home here, you have a lot of information here, tutorials, etc. Give them a try, okay? I have some videos specifically for Azure Machine Learning, how to work with this. Not so much about the machine learning itself, but the Azure Machine Learning. But feel free to have a look and try some of those out yourself, okay? Anyway, I have some questions here, so let me just answer the questions. What will be the learning path for a SQL DBA? Well, if you know this already from the session, the next path will be to try out things like going to github.com/Microsoft Learning /DP-203 something. So search for DP. So you go to GitHub, okay, github.com, Microsoft Learning, and then here you search for DP100, which is actually your best one to learn Azure Machine Learning, okay? You find the one that's English, which currently is this one. And from here, you just go here and follow these instructions here. So this is the address that you pretty much need, okay? Follow this from beginning to end. This will be very easy for you to follow, and you'll know everything you need to know about Azure Machine Learning, okay? Is it required to know, do you need to use Azure ML service? You can just use Python directly. You don't need any kind of paid service. Python is okay. Go to scikit-learn, so search online for scikit-learn. Online for scikit-learn, like this. Search online for this, and you'll find it. Okay, scikit-learn.org. Okay, this will be very easy to get you started. Also, do you require to know R or Python to get into ML? Yeah, pretty much, but you know, the language is not difficult. The trick is the library, so you learn very quickly if you're familiar with any language. For e-commerce website, how can be user ML serve? How can you use ML services? Well, that's a bit more advanced, but you get the data in a tabular form, and then you feed it to machine learning to some of the things like classification or things like clustering, the k-means, etc. And then you detect trends. That would be a question for a different day, because that would require like hours of explanation. But feel free to reach out to me directly if you want more information about that. Okay. And to do that, here are my contacts. Okay, because we are really running over 5 minutes of the next speaker. I do apologize for that. But in any case, I want to thank everyone, okay, for being here in the session. It's too much to take in just 1 hour. I do understand that. But if you have any questions, you are welcome to reach out to me on social network. And yeah, okay. So anyway, thank you all very much for being here. And I'm gonna hand this over to the next speaker, which is already waiting in line very patiently. But yes, thank you very much, everyone, and see you next time.
Thank you, Andrew. Thank you very much.
Okay, sorry for the delay.
It's okay.
That's quite all right. Thank you.
Hi.
Hello there.
How are you?
I'm doing great. Thanks for having me. It's a real honor.
Oh, we are very much excited to get your event today. It's a deep learning session, and we are very much excited. And also, it is the first time someone taking the session on deep learning.
Well, to manage expectations, we did set this as a two-part series.
Right.
So you can't really talk about deep learning without machine learning. And also, I'm trying to plug Azure Synapse, specifically from a data science perspective. And so, you know,